Hello guys, welcome to the channel. The problem that I will explain today is nearest smaller tower. So let's get started. Okay, so here is the problem statement and it says that you are given an array where each element array of I represents the height of the tower. Find for each tower the index of nearest possible tower that is shorter than it. You can look left or right on both sides. Let me explain this. Let's say you are given this array, and for this array the value in the array are 4, 8, 5, then I have 3 and 1. So these are the values in the array and each value represents the height of the tower. So I have towers like this is the tower of height 5, then I have tower of height 3, then I have tower of height 1. Okay, now our task is for each tower we need to find the nearest possible tower which is of shorter height. I can look for the left and right both sides. So let's say I'm at this point. So on the left side I will have the smaller tower at this distance, and for the right side I will have the smaller tower on this distance. Now as I need to return this like I need to return the nearest possible tower, so out of these two the nearest will be this 3, right? So this the index of this 3 will be the answer, which is 3. Now there is one more case possible. It's easier to guess the answer for this one, but let's say I have two towers like 4 and 3 like this. So you can see that now these two towers are at same distance, right? So which one is the answer in that case? We have one case for this. It says that if two towers are at same distance, then pick the smallest tower. So if two towers are at same distance, I need to pick the smallest tower, which is 3. I hope it's clear to you. But let's say in this condition as well, we have both towers of same height. Then which is the smallest tower? Both have the same height in that case. Okay, let me write that case as well. So I have 3, 3. So now you can see that these two are at same distance. In that case, I need to pick the smaller, but two towers have the same height. What to do in that case? In that case, I need to pick the tower with the smaller index. So I will pick this one. Now, I hope it's clear to you. So we can discuss this example now. Let's start with the first value. For the first value, on the left side, you can see that there is no any tower on the left side. Okay, so on the right, let's see on the right side. On the right side, I have the smaller tower at index 2. So index will be 2 for this. For this 8, you can see that I have this smaller tower on the left side, which is 4, and I have this smaller tower on the right side, which is 3. And both towers are at same distance. So which one to consider in that case? In that case, I am going to consider this 3, because if two towers are at same distance, then pick the smallest tower. So the index of this 3 is going to be 2. What about this 3? For this 3 on the left hand side and on the right hand side, I don't have any tower of smaller height. So I'll write -1. What about this 5? For this 5, I can see that on the left side, I have this smaller tower as this 3, and on the right side, I have this smaller tower at this 3, and both are at same distance. And the height is also same. So in that case, I need to pick the tower with the smaller index. So I'll pick this 3, and the index of this 3 is 2 again. Okay, now for this 3, which is the last element, there is no any element on the right, and there are towers on the left, but on among all the towers on the left there is no any tower which is of smaller height. So I need to write -1 here. Now this is the output. You can match the output with this particular output as well. Now I hope you have understood the problem well, and what interesting about this example is that this example is going to cover all the cases that are like important here. The first case is this -1 case, when there is no any tower of smaller height. The second case is this case where I have the two towers at same distance, and we have also covered the case where two towers are at same distance and the height is also same. Okay, now I'm going to move to the answer. Okay, so here I'm going to take the same example, which is I have the array and the values in the array are 4, 8, 3, 5, 3. Let's see this example. For this example, what I can do is I need to look for the smaller elements, like smaller tower on the left side and the right side, right? So I can do it. Let's look for the smaller towers on the left side first. So I'll store in these values in an array. Let's say this which is left. So for the first element, there is no any tower on the left, so I'll write -1 here. For this 8, the smaller tower it is at index 0, so I'll write 0 here. For this 3, there is no any smaller tower, so I'll write -1. For this 5, the smaller tower is at index 3. Again, you can see that the smaller tower is at index 0 as well. But I will consider this 3. The reason is I need to find the nearest possible tower, right? So this is not going to give me the nearest value. That's why I am considering this particular value. Again, for this 3, there is no any value which is smaller, so I'll write -1. This is about the left array. Let's see the right array now. For the right array, I'll start from this point, and there's a reason. First of all, I'll write -1 for this, and for this 5, I'll write here the index of this particular value is 0, 1, 2, 3, 4, 4. Now, let me tell you why I'm starting from right side. When I'm looking for the values on the left side, then for the first value, I know the answer is always going to be -1. Why so? Because for the first value, there is no any value on the left hand side as it is the first value. Okay. Similarly, for the last value, there is no any value on the right hand side, on the right side of the array, I mean. Okay. So that's why I'm starting from the right side, because I know the answer for this is going to be -1. Now let's see, for this the answer is 4, and for this particular value the answer is again -1. Why -1? Because there is no value which is smaller on the right side. What about this 8? For this 8, the smaller value is at index 2, which is the first smaller value, so I'll write 2 here. And similarly for this 4, the first smaller value is at index 2, so I'll write 2 here. Now I have built my left and right array, so we can calculate our answer array by these two arrays. Let's see how. I'll start with this index. So what are the values which are stored by these like arrays at 0 index? The values are -1 and 2. -1 means that there is no any smaller tower on the left side. So I'll go for this 2. So I'll write this 2. What about these two values? For these two values, I'm at index 1, and first value is at 0 and the second value is at 2. Both values are at both towers are at same distance. So in that case, I need to pick the smaller tower. So it is at index 2. So I'll write 2 here. For this, there is no any value. So like on the left side and the right side as well. So I'll write -1. For these values, again I have the same case. This is 2, this is 4, and this index 3, and these are at same distance. So in that case, even the height is same. I can't pick the smaller tower. In that case, I need to pick the smaller index. So I'll write 2 here. And for this, again the output will be -1. Now, this is the final answer array that we need to calculate. You can notice one thing from this. We have calculated our final answer in 3 steps. First, second, third. So we can write this. We can write our 3 steps as I'm going to write the steps. The first one is calculate the left array. What this left array is about? This left array is basically going to store the index of first smaller element on left. Similarly, I need to calculate the right array as well. So I'll store that. I'll calculate the right array. Right array is going to store. Right array is going to store index of first smaller element on right. Okay. Now, as we have calculated the left and right array, so we can calculate the answer. So use left and right array to find the answer. Okay, now let's start with the first task. So I have divided this problem into 3 simpler tasks, and I'm going to explain each task to you. Let's start with the first one. For the first one, I'm going to take the same value, same example. The example is 48353. For this example, our task is to find the first smaller element on the left for each value. Okay, how we can do this? Let me explain. First of all, I'm going to make an array. This array is going to store the answer. So I'm going to call this array as left array, because this is going to give me the left smaller element for each value. And I need a structure. I don't know what it is, but it is going to store the values on the left. Let's say I'm at this 5, then this structure will store all the important values, all the necessary values from the left. I'm saying that necessary value, you will come to know about this later. But first of all, let me make this all stuff smaller. So I've done a wrong thing here. Let me make all these values smaller so that I'll get some space to write. Okay, so I have these values. I'll start with the first index. I'll start with the first index. For the first index, I know that the answer is always going to be -1. So I'm simply writing -1 here. And I'm going to store this index here. Okay, now I come to this 8. And for this 8, I will check in the structure that, hey, what is the value which is stored by you? The structure will say, I currently have 0 as the last element that was inserted to me. I'm interested in the last element. Why? Because the last element which is inserted in the structure is going to be nearer element from the current index. I hope it makes sense to you. Let's say I'm at this value and this is the last index which is stored. So this will be, I need this. Why? Because this is the first which will to which I'll give the priority in order to get the nearest element. Okay, now since I'm at this index 8, index to 1, then 8 is the element here, and you can see that this 4 is smaller than this 8. So I'm going to store this value as my answer. I can write this condition as well, but I'll write this later. First of all, come to this particular value. Now for this value, I'm going to check every element which is stored by the structure. So structure is going to store 0 and 1 now because I have processed these two elements. Now I'll check for the first element. For this 3, you can see that the value at this index, which is 1, is 8. And this 8 is greater than this 3. So I don't need this value. I'm going to remove this value. What about this value? The value at index 0 is again 4, and 4 is greater than 3. So I'll remove these two values. Now, why I'm removing these values, I will tell you. But first of all, let me write what I'm doing. While my structure is not empty, and the last value stored by the structure, which is my array of structure of last. This is the last value which is stored by the structure, is greater than equal to array of I. Then I don't need that value. I'm going to remove the last value. So s of last, remove it, remove it. This is what I'm doing. Okay, and why I'm doing so, let me explain you. So basically what I'm doing is, for this current index, let's say this is the current index, so I'm looking for the first smaller value on the left, first smaller value. So these two values are not smaller, so I have removed these. But when I remove these two values, you may raise a question that, hey, these out of these two values, since you have removed this, but it may be possible that this 8 is going to be the answer for this 5. Let's say it doesn't make any sense, so let's say it is 9 here. So you may raise a question that, hey, this 8 may be answer for this 9, so why you are removing this 8? So let me tell you that this 9 is greater than this 8. So this 9 is greater than this 8. Fine. And this 8 is greater than this 3, which means that this 3 is smaller than these two values, which means that 3 is ultimately smaller than 9. So if 3 is smaller than 9, then why to store 8 in the left array? I'll try to store this 3, right? That's why I'm removing these values, because if these values are smaller than any of the value further, then 3 will also be smaller than them, and I will give priority to this 3. Okay, I hope it makes sense to you. So what I'll do is I'll remove these two values. Let me remove these two values. Okay, now I have removed these two values and my structure is now empty. So okay, I need to delete this part, and I'm going to remove these as well. Now this structure is going to store the answer of the index of this particular value, so it will store 2. When this loop is done, then what I need to do is, since I'm filling the array, I'm filling this array, so for this -1 output is -1. When this loop breaks, then this is using AND condition, then either this condition will be false or this condition will be false. Let's say if this condition is false, which means that stack is now empty. So if stack is empty, if this structure is empty, in that case I can simply say that, okay, my left of I is going to store -1, right? Okay, because the structure is empty, which means that no any value is on the left hand side which is smaller than the current value. Fine. Else, if this value is not if this structure is not empty, in that case the value stored by the structure is going to be the value which is smaller. Left of I will be the value stored by this structure. So I'll simply write here structure of last value in the structure. Why I'm saying so? Because I'm removing all the value which are greater. So if I found any value which is smaller, then this loop is going to break, right? So if this value breaks, this means that the current value is smaller, so that's why I'm storing. Now when I'm done with this task, then I'm done with the current element. So at last I'm going to store the index in the structure. Append I. What does this append means? I'm going to store the index as I have stored this 2. So append basically means if I do structure of last equals to 4, so and structure is like 1 2 3, so it will replace the value, it will make this 3 as 4, right? But I don't want this, I want to add this 4 at the last. So in that case I'll use the append, so that's why I'm writing 4 here. Okay, now I'll come to this 5. So this is what we have done. Okay, and we need to done this thing for every index. If you notice here, we are doing this thing for every index, but for every index from 1 to n. Why not from 0? Because for 0 we already know the answer, so we can simply write -1 here. So we'll start from the index 1. Okay, now we are done with this 3. I'll come to this 9 again, and for this 9 I can see that this 3 is smaller than, and this 3 is smaller than 9, and the index is stored by the structure is of this 3. So I can simply say that for this then answer will be 2. What about this 3? Okay, so before coming to this 3, I'll store the index of this. The index of this is 0 1 2 3. So I'll store 3 here. Now I come to this element, and for this element I can see that this value is something which is greater, so I'll remove this. And what about this value? This value is again equal to, not smaller but equal to, so I'll remove this value as well. And when I remove this, then the structure will be empty here, and if the structure is empty, in that case I can simply write -1 here. Okay, now we are done. We are done with the left array, and we have written this particular code. What does this code means? If you notice this code, then what I'm actually doing is I'm only interested in the last value which is inserted in this structure, right? And when we want to remove the value, then we are removing the last value which is inserted. So isn't it like last inserted value is going to be first out? So which data structure provides this particular functionality? A stack. Now you can notice at every point we are performing the function like a stack. So I can replace this append function with push function now, and it will make more sense here. So I can write push here, and I'm pushing the value of I. Okay, so this is what we need to do in order to solve this problem. Let me zoom out this page. So this is the code that you need to write in order to make your left array, and the code for right array is again going to be same. But before moving to the right array, I want to tell you something. This concept is known as the concept of monotonic stack. Monotonic stack. And the complexity, although it looks like I'm having two nested loops here, but still the complexity of this approach is O of n. Very interesting. I will explain you this. But before that, for the monotonic stack, there are a lot of problems which are asked by the companies. So I want you to guys read about this particular concept, and I'm going to attach an article which is related to this concept and the problem which are related to this particular concept. So talking about the time complexity of this approach, so although it looks like the time complexity is of n square, but it's O of n. The reason is how many values I'm going to store in this structure, because I'm removing the values from this structure, right? So what is the maximum value of what is the maximum number of values that I can store in this structure? I'm going to store n values, right? And I'm removing the values. So I'm ultimately I'm processing only n values in from the array. Let me explain how. What actually n square complexity looks like. First talk about this. So if I have two nested loops, I have for I equals to 0 and I smaller than n, and I plus plus. Then again I have equal to I equals to 0, I smaller than n, and I plus plus. Okay, so for this, first we perform n times, after that again n times, after that again n times, after that again n times, and this is going to move till n, right? So we are performing an n function out of n times. But for this particular case, we are running a loop where I'm performing operations of n elements in total. I hope it makes sense. Ultimately, I'm only going to process the n elements, but for this case I'm performing n elements again and again. This is not the case with this code. That's why the complexity reduces to O of n. Okay, now let me show you the code for right array as well. The idea is very similar, but there is a difference. For the right array, we always start from the reverse. Why? Because for the last element, we know that the answer is going to be -1. And even I have told this thing to you here. Okay, so this is how we are going to calculate the right array. I'm not going to provide a detailed explanation on this because I've already explained it, and this is going to make this video long. Okay, so finally, we have got a left and right array which are like this. Let's talk about how we can calculate the answer using this array. Okay, so in order to calculate the answer, first of all, I'm going to have a list which is going to store my answer. This is my answer list. Okay, now for each value in the left and right array, answer is going to be calculated from these two values. So for I equals to 0, I smaller than n, and I plus plus. There are some important cases which are needed to be considered. The first case is this one. If both values are -1, if like left of I is double equal to -1, and right of I is double equal to -1. Okay, so it's really going to be time consuming when I write left I, right I. So I'm going to write left L of I and R of I in order to avoid that this thing. Okay, so I can write answer of I -1 in that case. This is what I need to do. Okay, now I have handled two cases, but there is one more case. If these two conditions are not true, then it may also be true that either this is -1 or this is -1. So I'll write if L of I double equal to -1. In that case, answer will be right of I. So answer of I will be right of I. Okay, and else if I need to write else if here. Else if my right of I is double equal to -1, in that case answer of I will be equal to left of I. Okay, now I have handled these three cases, and when these conditions are not true, then I can surely say that both values are not -1. Like I have the values in the array instead of these -1 anywhere. Okay, so now how to handle these values? How to handle this value? I know that I need to consider only nearer value. Let's say for this 5, I have 8 and 4 here and 3 here. So you can see that this 4 is far and this 3 is near. So I need to consider this 3 to my answer. How to calculate this distance? If this is L of I and this is R of I and this is I, so this particular distance is I minus L of I, and this particular distance is R of I minus I. Okay, so I can use these distances if as if my I minus L of I is double equal to uh, okay, so if I minus L of I is greater than R of I minus I, what to do in that case? In that case, my answer of I will be L of I, right? Why? Because I know that the left one is nearer. As if my L of I minus L of I is greater than okay, so in that case I have written wrong condition. In that case, we can see that the right one is smaller, so I'm going to write right of I as my answer. And if this is smaller, in that case my left of answer will be left of I, right? Left of I. Okay, now I have considered at most approximately all the cases, but there is one more important case to consider. Else, what this case is? This case is if two distances are equal. So I'm going to write I minus L of I is double equal to R of I minus I. What this condition is? This condition is basically this particular condition. If two towers are at same distance, then pick the smallest tower, right? So I'm going to check which one is the smallest tower. So how to check it? If array of I okay, if array of left of I is greater than array of right of I, in that case I know that the right one is smaller, so my answer of I will be right of I. And as if my right of I is greater than, like I have array of uh, right of I is greater than array of left of I. In that case, I know my left one is smaller, so I can write answer of I equal to left of I. Okay, and else this case is very interesting. This says that both are equal, and even we have seen this case here, that if two towers have the same height and these are at same distance, in that case I need to pick the smaller index. So I'll write answer of I will be equal to minimum of L of I and R of I. This is all we need to do in order to solve the problem. So we can calculate the answer array using this approach. I hope it's clear to you. I hope it's clear to you. This is what we need to do. I have covered all the cases here. So now let me show you the code. Okay, so on the left hand side I have written the Java code, and on the right hand side I have written the C++ code and the Python code as well. I'll start with the C++ code first. Okay, now let me explain this. This is the first step that we need to do. This is the first step. You can see here that we are first making our left array, and after this we are filling our left array like this, and this code is very similar to the one that I have explained you. Okay, after this I am clearing this stack in order to perform the same task for the right array. Now when this loop completes, then I will have the left array and right array, and you can see the same code here as well. Okay, now I am going to perform the main logic that I have explained you. I have recently explained you this particular logic, how I am handling all the condition. Now you can see that if all both distances are equal, so I need to do something like this. If left one is nearer and the right one is at far distance, so I need to consider the left one, else I need to consider the right one. This is what I need to do, and this is where I'm like handling the case for -1. Okay, now this code is again very similar to the this code. There is one change that I'm using one n here. So but it really doesn't matter that whether you use n or -1, you can replace these n with -1 as well, like I have done here. Okay, now let me show the Python code. So this is the Python code. Here I am using Python list in order to like perform the operations of a stack. Okay, and again this is where I'm calculating the left and right array. Fine, and this is the main logic that I'm performing here. So now I hope everything related to this problem and the solution is clear to you. If you guys like the solution, then you can hit the like button and subscribe the channel. This is all about this video. Thank you.